Hello students, for the purpose of this video we're going to be in lesson 1.1 and I just want to begin and remind you that the first chapter of your text is a lot of review material, so some of these things may be familiar to you, but again the idea is to ensure that we review it and that you remember a lot of the vocab words, and that I'm also introducing you to the mathematical terms, so getting a little more formal. So we're going to start out by looking at a graph. Here you see the coordinate plane, a graph. You have been utilizing this throughout your mathematics career and you've been plotting points. And another name that we have for this is called the Cartesian plane. And on the Cartesian plane you have what is called the origin, and that's where your axis meets, and you see the dot labeled origin in the middle, and its coordinates are the point 0, 0. Which brings me to the idea of what is a coordinate. Well, a coordinate is just a location. It's a way for me to identify a location on my graph. And so I'm highlighting here in yellow the coordinate x, y, because we always read off our x coordinate first and then our y coordinate value. And we follow along our x-axis, which you see me highlighting this horizontal line here. That's my x-axis with positive numbers going to the right and negative numbers going to the left. And then after we find our value on the x-axis, we look at our y-axis, which is this vertical line that I'm highlighting, and we go up for our positive values and we go down for our negative values. And then the last thing we want to look at are quadrants. Quadrants are basically a region of the graph, so it's a way for us to be a little less exact, not necessarily giving a coordinate, but still talk about where a coordinate might be on the graph. So we go in a counterclockwise direction, starting in the upper right hand corner. I have quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. Now, one thing we want to be thinking about is applications of why we would plot points. So sometimes we'll have a lot of data and we'll want to plot that data to visualize the relationships between two variables. If you think about me giving you an Excel document right now with a whole long list of data points, you're going to be able to look at that and say, wow, this is a lot of data, but it's probably not going to be very meaningful to you. But instead, if you can go and plot that and put that on a graph, you then can start to compare the relationships, see if things are increasing, see if things are decreasing. Keep in mind that the point of this course is really to take the mathematics and the calculus that you will be learning and apply it to the actual fields that you're pursuing. A lot of you are pursuing fields like business or economics or accounting, and in these fields a lot of times visual representations are super important. You'll have board meetings where you'll have to create visual representations of information or data in order to be able to give it to your employees and make them better understand, what is the current situation of your company or your business. It can be super helpful when you're trying to make predictions about what might happen in the future. So if you look at this graph that I have on right here on this screen, you see that we're looking at temperature, degrees Celsius, and sales in dollars. And I'm not exactly sure what this is pertaining to. It's missing a title, which is actually bad. It should definitely have a title. That's not good, because then we don't know the context of what is it that we're selling or what is it that we're talking about. But because I see all these dots increasing, even though they are increasing at different rates, I can then assume visually that I'm probably going to have, you see I'm drawing these red dots that are somewhere over there, dots that are continually growing and increasing. As my temperature in degrees Celsius grows, so are my sales. So visually it makes it very easy for me to make a prediction. Now, once we have that scatter plot, we want to go and make what we call a line of best fit. So you can create a line of best fit, which is a line that attempts to touch as many of the points as possible. The goal is to get the points very close to this line, which can be done through a process called linear regression modeling. And actually, when you go into upper level math, we have this course called multiple regression modeling, which looks at more than just an XY relationship. So we know a lot of things in life has a cause and effect relationship, but it's generally not affected by one thing. For example, let's think about gas prices. Gas prices are going to be influenced by several different factors. It's going to be influenced by maybe the season, right? More people are traveling in the summer, so gas prices tend to be higher then, and they also tend to be higher around holidays, whereas, maybe low travel seasons, the gas prices are going to go low. Gas prices also become affected by natural disasters. So if you remember, there was a gas pipeline leak in North Carolina not too long ago, and when that occurred, gas prices raised significantly. Other things, when it's politics season, gas prices tend to fluctuate as well. So there's a lot of different factors, and that's when you get into this idea of multiple regression modeling and seeing which factor has the most impact. But for the purpose of this course, we're going to focus on linear regression modeling. Again, the point here is to look at all of your data points and create a line that best fits that data. So the distance between each point and that line of best fit, you want it to be extremely small. And we call that distance our residuals. If you want to jot that down, residuals. And residuals are just the distance that a data point is away from our line of best fit. So the goal is, when you create a line of best fit, to have very, very small residuals. Now moving forward, we're going to talk about something called the distance formula. So we're kind of switching gears here. But when we think about the distance formula, it essentially exists because it allows us to effectively find the distance between 2 points on the coordinate plane. So all of this information that I have right here, I've put it in braces. This is kind of the background information, more about the proof. In the next slide, I'm going to give you the actual formula. But the way that we get the distance formula is we're basically looking at 2 points. So you see I have this point in red here, and I have this other coordinate here. And we know that the distance between any 2 points, the quickest way to get to it is a straight line, which is great. However, I can't really measure that distance. I can't just look at that graph and accurately measure it. So instead, I need to look at the change in my horizontal distance versus my vertical distance here. And you notice that that creates a triangular shape. So if I look at the horizontal distance, and that goes between my values 4 and 1, because I'm looking at here 4, that goes here, and then 1, which is here. And then I look at my vertical distance between the points 9 and 5, so that's because this point is here, and then this point is here. You see my orange highlighter. If I solve those, I get respectively 3 and 4. And knowing that I have a triangle, we know that a squared plus b squared equals c squared. We learned that in a geometry class at some point. That's our Pythagorean theorem. If we actually solve that and plug it into our distance formula, we find that this does create a true statement, and therefore we can find the distance of that hypotenuse side. Okay, so with that being said, here is our distance formula. I'm not going to stay on the slide too long. I encourage you to go ahead and pause this video, and then you can jot this down. So looking at an example on your own, again, I encourage you to pause this video. I would like you to find the distance between these 2 points. I would like you to give an exact distance as well as an approximation. When I say give an exact distance, it means do not round. You are giving an exact value. It would generally include a radical. Looking at my solution, I've identified my first coordinate x1, y1. I've identified my second coordinate x2, y2, and I've plugged these in respectively into my formula. Then using order of operations, I'm going ahead and I'm simplifying and solving until I get down to the square root of 160. And you see that my exact final solution is 4 square roots of 10. And then if I'm going to round that, I'm circling that, it would be 12.65. I want to take a quick moment to review how to simplify the square root of 160, just in case it's not something that you remember. Several ways to go about it. I like to do the tree method, and that includes thinking about 2 numbers that multiply to give me 160. And that would be the numbers 16 and 10. 2 numbers that give me 16 are 4 and 4, and 2 numbers that give me 4 are 2 and 2. I'm going to break down this 4 as well. And 2 numbers that give me 10 are 5 and 2. my goal is to break down numbers so that I cannot break them down any further unless it's one in itself. So for example, the number 2, I can't break that down anymore because its multiples are 2 and 1, and so I don't need to worry about breaking that down anymore. I'm then going to look at the ends of my stems, so that includes these numbers that I'm highlighting and these values here, and I'm going to write them out. So I have the numbers 2 times 2 times 2 times 2 times 2 times 5. And writing it like this shows me that if I were to actually multiply that 2 times 2 times 2 times 2 times 2 times 5, I would actually get back to my original value of 160. But now I'm going to make groups of 2 because I'm dealing with the square root, so I'm going to make pairs. And every time I make a pair, I'm going to take that to the outside. Here's another pair, so I'm going to multiply a 2 to the outside. Why am I taking it to the outside? Well, when I make a pair, that's 2 times 2 is 4, and the square root of 4 is just 2, right? So that's all I'm doing is I'm taking the square root of 4. So I have a 2 to the outside, 2 to the outside. I have this 2 and this 5 that I can't make pairs, so I'm going to leave them on the inside and re-multiply them. So 2 times 5 is 10. And then to simplify, 2 times 2 is 4, and then my square root of 10. And that's how we break down radicals. If that's something that you don't really remember and you feel like you need more practice, please let me know. I'm happy to help. It may be something that I need to give you some resources, or maybe we can sit down and work out some extra problems together. Now, verifying a right triangle is something that I want to expose you to. It's not something that I want you to stress about. I'm not going to test you on this, but again, it is something that I want to expose you to. It says utilize the distance formula to show that the points are vertices of a right triangle. I've given you the coordinates along with the first 3 steps. I'm going to encourage that you pause this video, write down your steps, begin to graph and plot your points, and see if you can work through this problem, as on the next slide I'm going to begin working out the solution. So you see that I've gone ahead and plot the points to outline a triangle, and so the next thing I'm going to do is utilize my distance formula to solve. So I'm going to look for the distance of side 1, and when I plug that into my distance formula, I have 5 minus 2 all squared plus 7 minus 1 all squared, and if I solve that, I get the square root of 45. And I'm not going to condense that down anymore. I'll leave it as that. When I look for the distance of side 2, I have 4 minus 2 all squared plus 0 minus 1 all squared, and when I simplify that, it gets me the square root of 5. And when I look for the distance of side 3, I have the square root of 5 minus 4 all squared plus 7 minus 0 all squared, which gives me the square root of 50. And since I know that this forms a triangle and I'm trying to verify that it's a right triangle, I'm going to use the Pythagorean theorem, which says the side of 1 plus the side of 2 all squared should equal the side of 3 all squared. If that's true, then I'm dealing with a right triangle. So I'm going to go ahead and plug in my values. The side of 1 is square root of 45, and I need to square that, plus side 2, which is the square root of 5, and I need to square that. And this should equal the square root of 50 all squared. And sure enough, I know that the exponent and the radical cancel each other out because they're both squared, so that happens on all of these. And 45 plus 5 is in fact 50, and that is equal to 50, and therefore I do have a right triangle. The next concept is talking about a midpoint, and this is fairly simple to think about because it's literally what it sounds like. The midpoint is the middle point between 2 points. This is something that we do all the time. When you think about maybe you live in Smithfield and your friend lives in Raleigh and you want to meet halfway, you measure the distance between the two of you and you divide it in half, and then you find, a middle location. So that's exactly what you do when it comes to coordinate points. You add the x values together, divide by 2. Add the y values together, divide by 2, and that gets you to the middle. So if I ask you to find the midpoint of the line segment with the following endpoints, again, you're going to add your x values together and divide by 2, and then you're going to add your y values together and divide by 2. If you look at my solution, I have done that. I've added the x's and divided by 2, added my y's and divided by 2, and I end up with the final solution of 0.7 as my x and negative 1/2 as my y. Again, you can pause this video. Here's another example to find the midpoint of the following line segment. If I add my x values together and divide by 2, I end up with an x value of 2. And if I add my y values and divide by 2, I end up with a y value of 0. So my final coordinate midpoint is 2, 0. Okay, I hope that you found this video helpful. As always, if you have any questions or concerns, please don't hesitate to reach out to me. I am more than happy to help, and I hope you have a great day.